A lot of the announcements coming out of DRD is MR, manufactured readiness. Maneuver without regret is a driving factor for us. We're in the middle of a space mecca.
So, hey, welcome back to the Aerospace Executive Podcast. I'm really happy to have Paul Worley on with me. Paul is the president CEO of a small microcap company out in Colorado called Ascent Solar. And we just started talking about it. I love the technology that you guys have been developing.
Well, thank you.
It's thin film solar panels.
Let's show your viewers.
There you go.
So it's very thin. Okay. And it rolls up like Christmas paper. Okay. So the advantages are it's very, very light. So if you're putting solar up in MEO or GEO, it costs a lot of money per kilogram. And so we save on the costs. In addition, if you want to roll it up, slide it up, or whatever, we're not silicon, so we don't break. So that's the other big advantage. So what the signaling we're getting is DOD wants to have, maneuverability without regret. And this enables maneuverability. It's hard to move a satellite with a 20-foot array on each side. Whereas you can do it, it just requires more energy. So anyway, that's kind of where we're positioning ourselves right now.
So let's talk about, you guys have been around a while, and
Yes.
The company, you've been developing a product for 16 years now.
I was brought in as a CFO in 2022. They made me the CEO in 2023, April.
Right.
And basically I sat everybody down and said, look, in order to get into the space market, we have to get our efficiencies, somewhere around the 11.5 or 12 range. So Bobby Galati, our COO, and our team went to work. We hit numerous milestones, and about early 24, we crossed 12%. We got very close to 12%, and that opens up some market. That opened up some markets for us in space. Then we eventually hit close to 13%, and so that's the good news.
So everybody's talking about solar, green energy. It's the wave of the future. The worst things I see out in the North Carolina cornfields are these solar farms.
Yes.
Yeah. Two things I can't stand as I drive up the coast. I see the big solar farms and the wind turbines. Wrecking the aesthetic of the coastal environment. But you guys are thin film. So, you're taking these big, thick, foot wide solar panels. You're putting them down to a paper. Yeah. Size of a piece of paper, putting them on airplanes. Is this the future? What's going on here?
The deal is silicon is so much cheaper, Craig, to manufacture. So it's funny because a farmer had to make a choice. Okay. And we really didn't have the production. I mean, we have approximately 5 megawatts of production, and in a typical cornfield, let's call it. If you wanted to put our stuff in, the farmer might have wanted to produce 20 megawatts. So we couldn't even have produced it. Okay. To be serious. So, we're a great alternative to that. But it's going to take a while to convince the agricultural community that you can put our product. We're going to be at somewhere between 18 and 22 feet above the crop. There's a gap, so you get rain and sun come through, and you get somewhere between 95 and 100% of all the crop production. So the deal is you got to look at it that you're going to have less electricity being produced as an income, but you're going to keep your income from a farm. And so that you can't just do that overnight.
So you're seeing a lot of, it's a market for thin film solar is developing.
Yes.
Obviously satellite, look, Blue Origin just, launched their rocket, successful launch of their rocket the other day. SpaceX is going crazy.
Yeah.
United Launch Alliance and Tory Bruno, they're doing the same thing. So, and they're carrying, payloads are getting, more abundant, I want to say, more satellites in a payload as the satellites get smaller. So is this where your market really is?
A lot of my market's there, but I'll explain it. There's also some other up and coming launch companies that could put 2 or 3 satellites up.
Firefly.
Firefly, but there's some other ones that are in the background. But that could be very key to DoD too, because if our adversaries take out a couple satellites, to be able to immediately put up another satellite to replace that satellite is key. So, but anyway, those are going into LEO, lower Earth orbit.
Mm-hmm.
If you can get, the issue is Blue Origin and SpaceX are going to drop the cost by about 70% with the reusable rockets. Okay.
Right. But
they have to be full. So there's a lot of things going on that nobody knows.
You talk about thin film. I mean, essentially, you're developing it. When you and I talked last week, you said it's very hard to produce. Talk about, what's, technology's happening. Production is hard right now. What's that all looking like for you? Or what's it looking like as an industry for the solar, for solar in general?
The other thing we're getting some indications in the last couple of weeks in space, we've gotten a couple of inquiries where they're not going to use a deployable. They want to wrap a product around a satellite, or wrap a product around a refueling station or something like that. So that's really, I don't want to say we're it, but we're close to being the only solution. So that's starting to emerge. But so what we're doing here, we're constantly trying to improve. We took one of our SIGs equipment, which is really our patented manufacturing process, and we're doing some modifications to that and using a 3-chamber rather than 5-chamber. So we're hoping to get some good outcomes with that, but I'm not going to know for another 2 or 3 months, probably.
You've got a team of engineers out there. What's it taking? Who? Is DARPA, is DoD funding you guys? Are they giving you some investment money? Obviously, no. What's your engineering team looking like to advance on this?
Well, I've got all the fixed cost, Craig. That's good and it's bad. It's good that I can do some R&D with it, and it doesn't cost a tremendous amount of money. But B, it is overhead.
Is it a competitive market? Are there a lot of other producers in the thin film area, or what's that all? What's it all looking like?
Well, there's a group in Japan that doesn't do it on either a thin sheet of metal or glass. So they're going to get a higher. If you do it on a hard surface, you'll get a higher output. But they shut their operation down about 5 years ago, and I think they're bringing it back up. But they're having to bring it back up by buying new equipment. They disassembled everything and off it went. So they're starting from scratch. But that is primarily a true thin film that I know. We have a couple other competitors that are in between thickness and weight between us and other silicon. And then you have two types of silicon. You have just regular kind of silicon wafers, like that a Starlink would use, and not Blue Origin, but Kuiper use.
Space unfolds. How do you see? What's the market looking like moving forward? Is this where everything's going, or is this where everything's going? Even despite the fact that it's a little more expensive, but lighter weight.
There's two things. There's also something else that's happening out there. You see people talking about beaming or lasering power. Like 6 months ago, I wasn't even allowed to use the word laser. Okay, but now I can. But they're lasering power. I'll just say our stuff does very, very well in the lasering world, receiving a laser, because we're so thin. The constraint there is heat dissipation, and we're thin, so we were able to dissipate heat on the bottom. And our backer, which is Moly, is a heat dispenser. So we'd work very well with laser or concentrated power. So that's going to hopefully open up a bunch of doors too in the next 6 to 12 months.
So you're a small publicly traded company, microcap. What's the future look for you guys as far as a growth technology developer? Is being small an advantage? Does it allow you to get in, get out, be nimble?
It allows us to fill orders quickly. So as well, a lot of the announcements coming out of DRD is MR, manufactured readiness. So, outside of some of the large 4 or 5, maybe 3 satellite producers, and they're producing them for themselves, not producing them for others. Outside of those folks, the order sizes might end up being, even though there's more and more power being needed, but you'd be looking at, call it a couple KW to a couple hundred KW outside of the big guys. So I think the future is some smaller orders, or if we get into the power beaming and other stuff, that opens up the door. But then the panel, I would call it, that they're beaming power to doesn't have to be extremely large. But we have to do some special stuff to the array itself. But anyway, so that could open up a lot of doors, and then that'll be multitudes of smaller orders.
Yeah, what's got you really excited about? I mean, what's got you excited about the future? What's happening in industry? What's happening in the world that's got you guys really excited?
Couple of things are happening in. Let's use it under the DoD umbrella. So that would be Army, and Space Force, and Marines. So, and the Navy too. The Navy has actually gone into trying to produce these early warning devices and putting them on the water, and they need solar. We had a couple of inquiries several months ago. Don't know where that is, but that's an area. We'd just call it that, the Navy. Army and Marines, as they put more drones out, they're going to need to charge them. I have some key calls in a couple of weeks, and so we'll see where that goes. Because those people could actually say, I'm going to order solar, and I'm going to do it. We'll order it this way, and we're going to put it on the backs of the troops. Okay. So we'll see where that goes. So in space, maneuver without regret is a driving factor for us. Okay. And we're getting ready to go through atomic oxygen testing and radiation testing. And if that comes out positive, then, which I'm thinking it will, especially on the radiation side, then that could open up some more things. So MEO and GEO are high radiation, low atomic oxygen. LEO is high atomic oxygen. So we've actually had some customers test our stuff in the last 2 weeks and came back with very positive comments. So anyway, waiting on pins and needles on that one.
Let's flip the script a little bit. Is solar going to be, I mean, how, is solar film, are we going to start to see it more and more and more in our daily lives? Or you start to see it in the roofs of cars and, lightweight, thin solar panels and, power and batteries, powering our houses, sitting on our roofs? Is this the wave of the future, or is it, are we going to stay a natural gas, coal, and oil society?
That's a good question. Okay. Because I've been in that arena for a long, long time. This is personally now. I would say that, hybrid cars are going to be more prevalent than electric cars. Having said that, electric cars have a great, nice niche. If you drive 5 or 10 miles a day, you go to work, come back, they're a great vehicle. Okay. If you wanted, and now, Tesla has all these charging stations, and then they also have programs to tell you, if you stop here, you can stop for 22 minutes and then you can make it to your destination after this one stop. So there's a lot of technology around it that, so I think there's definitely a place for electric vehicles. I don't think so. I don't, Ford announcing they may or may not do the 150 pickup. I think that had to be, that was more of an issue with the clientele. I mean, the 150 pickup is used primarily in construction industry, and when you put heavy stuff on the back, it reduces the range of a pickup dramatically, or if you're towing stuff. So that's where I think that's where their clientele had an issue with the 150. If you do, I think trucking, there's some nice electric trucks out there, and you can lay solar across the top of, and there's people that do it, the top of a trailer. They could charge the truck.
Refrigeration systems or whatever else in the truck, right? Or
the only issue with that, when you start trading, the bottom of the solar is putting off a lot of heat. So then you have to create a trailer that is insulated even more. Otherwise, you can't cool something that you're heating up at the same time. I know there's technology out there that'll do it, but that's one of the things they had to first overcome. But refrigeration is actually a decent thing. You could put it on the, most trucks have that windshield on top of the cabbie. You can put it there and at least keep the refrigerant. You could have some batteries and keep it. It uses more or less electricity, but it pulls it off the truck. Well, now you're not pulling it off the truck as much, so you get better gas mileage on the truck.
What about you talked about some of the challenges of heat. What's the challenge of putting like a thin solar on an aircraft? Where what's the technological challenges of solar? You put it on an aircraft, and maybe it powers some systems or helps you reduce some battery weight or something like that. But you talk about, I guess you're talking about, hey, look, every good deed, no good deed goes unpunished, right? You put you put a solar system in, but now you got to figure out a balance away with insulation.
Yeah, with an aircraft, there's quite a bit of layers of stuff, but you could put it on the fuselage and the wing if you were going to use an electric motor. Um, I, it you couldn't put like a high like gallium arsenide on the outside of a plane is too heavy. It'll generate a lot of power, but it's just too heavy. You could put our stuff on. The question is, how much could we extend the life of the batteries and for flight time? That's the key. And as a plane, it uses the taking off and landing is where it uses the most energy.
Mm-hmm.
So technically, if it got it up in the air, and then it replenished the batteries as it's flying, then that's great. But where do you fly the most long term? Transatlantic or trans-Pacific, and you take off at night and you land at night and you land the next morning. So that's the other issue. You'd have to kind of re-scramble everything, but then the businessman wants to take off, one afternoon and he wants to land in Europe the next morning.
Right.
So that kind of messed that up.
So yeah, so I guess
It's not an easy answer.
Right. So a lot of people have some really good theories as to how it works, but yeah, the reality sets in. So ultimately, it sounds to me like you're kind of looking at the future is really space. Are the satellite developers coming to you and saying, "Hey, help us solve this issue"?
We've had some. Either the deployable companies or the satellite, what's called bus manufacturers, are coming to us. So what happens is if somebody needs a satellite, they'll go to, one of the top, let's say 1 out of 5 bus providers if they want, 20 or so. And then those bus providers then will make a satellite for them. They would like to have the minimal amount of changes, but if the person that's going to buy the satellite needs certain results, then we do very well when they need high voltage.
Okay,
that's where we differentiate ourselves.
So is that where? So are you working with and that's where are you guys talking to the satellite guys? Say, look, for high voltage, we're the solution.
We're starting to talk to that. When you get into manufacturing and power beaming, you need more voltage. So that's what Novi is doing. Knock on wood, we should have another one that's going to be doing manufacturing in space. Anyway, and again, it starts small and then moves to bigger orders.
Manufacturing in space.
Correct.
You want to expand on that a little bit? What are you talking about? Yeah.
Well, you have, for instance, if you go and look at the video on our website, we have this massive plan, and then we show you the SIGS machine. It has 5 doors. It's freaking, 20 or 12 to 15 feet wide. Maybe not that far, 8 to 10 feet wide. And then it's 48 or 50 feet long, and it's tall. If I were to go manufacture SIGs in space, my piece of equipment would be 15%, it would be 85% smaller. Why? I don't have all these chambers that I'm having to take out gravity and do that. So I go to where I reduce the atmosphere. So all those things about these huge pumps that are because I spray my product out, so you want it to settle down. So in space, if I were to do that same manufacturing process, my equipment would be so much smaller. And so a lot of drug companies and other companies that need to manufacture in a vacuum or so, it's actually less expensive to manufacture that in space if it's smaller quantities. So if you need, if you're selling 20,000 pills a month or a quarter. And this is high cost pills, but it's a limited audience. It costs a lot to manufacture that on the ground, but if you send it up into space, it's not as expensive to manufacture. So it's all has to do with weightlessness.
So pharma. So the thoughts of pharma, these data centers, people are talking about putting data centers up in space,
Yes.
natural cooling. Yep. So this is real, and you guys become the power. You guys become the power that defines it.
The other thing is manufacturing components for a satellite. So, for instance, you can manufacture, let's say, an array, or you can manufacture outer components to a satellite, and then so you could just send what you send up is something smaller, and then it assembles in space.
Interesting. Thus the need for more rockets and SpaceX and Firefly.
Yes,
et cetera.
Yeah.
Interesting. How far off are we from seeing this become? I mean, I go out to the beach a couple of times a month and I see a SpaceX rocket launching into orbit, coming up the coast and launching. How far away from this just becoming a everyday occurrence, or been there, done that?
SpaceX is manufacturing enough rockets to where they could fly 4, 5, 6, 7 times a day. And Starship can carry 4 or 5 times the weight of a Falcon Heavy. So when they start really doing that, they just announced. I think they just announced. You've checked with it. I think I read something about them. They're producing 20 Starships. So that's going to change everything. That's going to put a lot more stuff into space. It's also going to potentially create a lot of space debris, and space debris could cause a lot of problems for LEO. So you're also reading about people wanting to go to MEO or GEO because it's not nearly as crowded.
How does that affect you guys, though? I mean, you're a small provider. Do you see some pretty rapid growth to meet the, people are going to start manufacturing up in space? Do you see
MEO and GEO pose a good situation for us because there's high radiation and we do well in radiation. So that's an issue, and weight matters. It'll still matter even with these new rockets. It costs a lot more to get your satellite up to those orbits.
So you're a growth company.
We've got a lot of positive things right now.
You're optimistic about your future.
I'm optimistic. Yes.
Is thin film going to be? I mean, obviously you make it in the United States, but you said it's a little bit pricey. Is the cost of that going to come down? Is the demand of it going to justify the cost?
Once orders start coming in, Craig, then I'd have to look at, bringing in some new equipment. If I brought in new equipment, I could reduce the cost significantly.
Is there a moat for you? Is there a pretty good moat for you guys from a competition standpoint, technologically?
Here's my moat. Here's my big moat. We spent over $220 or $250 million, and it took the company back then about 8 years to get to where they are today. So it's not necessarily an issue of, could somebody do it? They could, but it would be expensive to do on polyimide thin film.
So a lot of CapEx, a lot of R&D and CapEx expense to get into your world.
Correct. That's my biggest deal. But silicon is silicon. It's still cheaper. And the other thing is Moon and Mars are primarily silicate. So you could technically manufacture on Moon and on Mars, you can manufacture silicon. Now, what that means is they could take our stuff up there to give them the original power, and then they can manufacture their own silicon up there too. So that's not necessarily a market that we'll miss. We'll potentially capture the front end because our stuff is so much lighter and be so much cheaper to put on the Moon.
So last question, Jim Farley at Ford. So he's got 5,000 open mechanic positions he can't fill. You're a very technologically advanced company. What do you need from what do you need from a people standpoint? Can you find the people? Can you find the technicians? What do you need from a skill standpoint to grow?
That's a good question. We go over that probably every 4 to 6 months. We have a list of people we could go out and contact. I don't need an engineer necessarily to run the equipment, although almost all of my equipment today is run by engineers. But I don't need that. I just need somebody who's experienced in running larger equipment. The crazy part of it is, there was some senator on about this morning on CNBC about AI and, people graduating from college, not having jobs. It's, if you go to a trade school right now and you come out to be a plumber, electrician, or an HVAC, you're going to make more than most of the college graduates that are going to come out with a finance or accounting degree.
Mm-hmm.
And you didn't have to go and pay for all of that. That's where you can't AI air conditioner repair. I can't AI running my equipment. I think it's so the younger. I would say the people that are coming out of college or getting ready to enter college, maybe you ought to think about, going to do a trade because they're getting well paid to do it. You have standard hours. You got and the benefits are great. So anyway, that's going to have to be a fundamental change. But we're in the middle of a space mecca, and some of the larger guys are, moving plants or doing this or doing that. So we think we can hire, 20 people within, 5 to 8 weeks if we would need to crank this up. And that's probably all I need. That would be all I needed right at first.
What about from an engineering standpoint? As the technology develops,
I might need to hire a couple engineers, but primarily it would be equipment operators, which would be the same as mechanics, HVAC. We can go down that list. Yeah.
Very cool.
Anyway,
I love it. Paul, thanks for coming on today. It sounds like you're excited. You're excited about the market and where you guys are going.
I am. So
awesome.
Thank you for having me.
Paul, thank you very much for the conversation.
All right.
Look forward to watching I'm looking forward to watching your success.